Bismillahirrahmanirrahim. This is a June 2020 41 variant, question number 7, and topic is a linear momentum. Uh, sorry, and some part is a combination of kinematics plus Newton's law. So have a look here, students. First part is what he says. A particle of mass 0.3, smooth plane is a smooth plane, inclined at 30 degree. Okay, released from the rest. So it means starting velocity 100% zero. Okay, data is written already, so I will not write again. So distance is 2.5 meters. So, and then reaches to horizontal plane, reaching here. So I just make an extra part here. It will reach here. Okay, and the same velocity, it will go from here, reach here. I believe the point is very clear. Okay, so and he said that there is a no change in speed when P reaches the ground horizontal plane. Sometime it happens realistically when its speed hit a particle hit here in the ground, some speed changes. But he said no change. So what is the velocity here? Same velocity here. Okay. It means the end velocity of this motion and starting velocity of this motion are equals to each other. And mass of Q is given 0.2 mentioned here, and at rest it means velocity is 0. So I'm writing here velocity is 0 here. This velocity is 0 here. Okay. And afterwards he's saying 1.5 meter from is a distance given here. So he's asking that P collide with the Q. So ultimately P will come down and hit with the Q. So he's asking that is given that horizontal plane is smooth. So this is a no friction at all. First of all, here no friction. So after collision, P comes to the same direction. P continue to move in a same direction, speed of 2. So the speed of Q after collision. But we can't go for it. First of all, we need to find this velocity. For this velocity, we have to work on it. So how to get this one? Okay, look at here. Last velocity is my question. I talk about inclined motion, inclined plane motion. U is confirmed 0, S is confirmed 2.5. But problem is that, do we have acceleration given? No. It means if we don't have acceleration for this motion, we cannot solve the question. How we can solve it? So inclined plane, a particle is weight component, mass is a 0.3, and you know it very well. We done in chapter of Newton's law. This is a 30 degree, and mass is a 0.3. This is a 0.3 into 10, 3 newtons. And you know it. This is always 3 sine 30, and backwards always friction, because system is going this way, motion is this way. So I can say here net force equals to ma. Okay, and I can tell simple and clear. So this is a weight component. I can write it here mg sine theta, or I can write here 3 sine 30 minus friction force acting backwards equal to ma, and mass is what given by him is 0.3a. So 0.3, but as friction is 0, so this is 3 will go down, and 3 sine 30 divided by 0.3, and this is 0. You know it very well. And if I check it in calculator, I get this answer is 5 meter per second square. So alhamdulillah rabbil alameen, this R5 I will use here now. So formula is 2as is equals to v squared minus u squared. 2 times 2 acceleration, which is a 5. Distance is traveling is 2.5 meters. You know it very well. And last velocity is my concern, is my required u0. So when it this 2 for the 10 2.5 is 25. So v square equal to 25, and take a root, it's got a 5 meter per second. It means this particle will hit the ground with speed of 5 meter per second per second. Okay, so this is clear. Now student, we have to go for this is clear. Go for further concept. You know it very well. This is a particle before collision and after collision story. We have go for it. Is a particle 1, and here particle 2nd. Okay, it's very clear. And now both system I'm going to paste here. Okay, and now Student, very clear. This is a this because you talk about P and Q particles. This is a P particle, Q particle, P and Q. Okay, and now I talk about hitting point. Okay, a hitting point, because is a this is a smooth surface, so no friction is here. If no friction here, so what is speed here? Speed throughout remains same, and I believe this part is very clear. Okay, so let's proceed. What is the P? 0.3. So 0.3 kilogram, and point Q is a 0.2 kilogram. So 0.3, 0.2. 0.3, 0.2. Okay, P is going towards Q by with the speed of what? 5. U1 is equals to 5. And Q is at rest, because you know that Q is at rest. So naturally, this will go this way, and this will go this way. V1, he mentioned very clearly that after collision, the P will move speed of 2. So V1 is 2, and speed of Q we don't know. Now we can apply formula M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So 5 into 0.3, if I multiply, because mass into velocity, so I get what directly I'm writing here, I'm saving my time, 1.5. 0 into 0.2, I get 0. So 2 into that, I get 0.6. So V2 into 0.2, I got 0.2 V. It will go and subtract from here, and I will get ultimately 1.5 minus 0.6. So this is 0.9, 0.9 divided by 0.2. So answer is coming 9 by 2, or I can say 4.5 meter per second. So Alhamdulillah Rabbil Alameen, after collision, this velocity of Q is clear. And Alhamdulillah, 5 marks are confirmed from here. Next 5 marks is given that instead the horizontal plane is a rough. It means inclined plane still smooth, but the horizontal plane is rough. And the PQ is, they collide, they coalesce and move with the speed of 1.2. So story is what I just tell you. It means it means this is a situation. It is here coming, and further it goes this way. And sorry, he said that horizontal. Yeah, this is a smooth here, no friction. Still same story. P is starting from here and reach here. Okay, hold on. Reach here, and then we make another particle here, paste, and then we can make it here. So this is a Q particle. So naturally what happens, this is coming this way. First of all, the same speed, you know it very well. This speed is what? This speed is 5, and this 5 and this 5 same, you know it very well. Okay, okay, I will take this is a I will take the same for U5 here. Okay, now it will go and hit here, and there's a 1.5 meter distance from here to here. Okay, there's a Q particle, there's a P particle, there's a P particle. Okay, but this is it has a friction, so friction is not equal to 0. Make sure it's not equal to 0. Now what is technique here? So they will hit. Okay, so let me do the same story here. So this particle, wait a minute, I make it again here. Okay, so I do the same story once again. Okay. All right. Before collision, after collision. This is before. This is after. So let's talk about P and Q. P and Q. Okay. You know what happens, students? P is 0.3 kilograms, and there's a 0.2. Let me recheck. 0.3 and 0.2. Correct. So 0.3 and 0.2. All right. So what will happen, students? Make sure what he said, after collision, after they will coalesce and we move 1.2. So it means I will bring them together. They will become a one object. Okay, they will move together and they will behave as a one object. Okay, and speed of the particle combined motion is 1.2, he said, according to situation. Okay, and this speed is very, very clear. This speed is just, okay, problem is that, sorry for that, 1 minute, please. He says, very clear situation here. Wait a minute. He said that instead of horizontal plane rough, okay, yeah, here, but just before hitting, for example, this is a Q. This is Q. Okay, and this is a P. Okay, there's a P going to hit. So, this is a 5, no doubt about it. But what is speed at this moment, just before hitting? We don't know. So that is why I taken as U1 is equals to unknown. And U2 is confirmed 0 because it's at rest. And after collision, they are moving together. I repeat my words. I don't talk. This speed is confirmed 5. But after, due to friction, the speed will reach here, not 5. It changed. So just before hitting, this speed is unknown. So I'm using to find this one first. M1 U1, M2 U2 is equal to M1 V plus M2 V. Why V be same? Because they're moving a combined speed. So U1 into that. So I can 0.3 time to U1 and 0 into that, we got a 0. And this is combined, so it very well 0.2, 0.3 become 0.5 into V. So if I check it from here, and sorry, V is given by him 1.2. So it means into 1.2. And it very well 0.5 into 1.2, I get here 0.6. 0.3 U1. So U1 is turned to be here 3. So U1 is turned to be here 3 meter per second. Wait a minute, sorry, put 3 to the 6, so 2 meter per second. Okay, so 2 meter per second. It means you can say that just before hitting, this is this 2. So now our story is very clear. I talk about this situation. Okay, so this speed is 5, as U is 5. And this speed just before hitting is 2. And this I'll call as V. So U1 will give a name as a V now, no problem at all, because is a P particle is going there. So I believe this clear. So this is distance is 1.5. So distance is 1.5. So what is the problem left? Only using this data, I can find acceleration. So let's try to find. So 2as is equals to V square minus U square. Now you can ask me, so why you find it so? Hold on, I just tell you. So 2 square minus 5 square and divided by 2 and divided by 1.5. It is giving me what? It giving me it giving me -7. So deceleration is coming negative. But recheck once again. Wait a minute. Last velocity 2. So 2 square minus 5 square and divided by 1.5 and divide by 2. So I'm getting answer -7. Okay, it means deceleration here -7. But student, now I talk about that situation. You know it very well. When any particle moving right hand side with applied force, backwards is a frictional force, and what is the basic rule to use? Net force equal to ma. Net force equals to ma. Applied force minus friction force equals to ma. But because we talk about this motion, no combined particles are there. Okay, so what is the mass of P? That is a 0.2, 0.3. It work only. Applied force not there because it is sliding to its own weight only. Okay, so 0 minus friction is what? M is equal to mu r. All of F is equals to mu r. Okay, mass is 0.3. Acceleration I just got -7. Now, thing is that what is this one R and what is this downward acting is a weight component. So what is the weight component? W is mg. So mass is a 0.3 in G is 10 always. I get a 3. So newtons. So there's 3 newtons. So R value is 3 newtons. So I get negative mu into 3 equals to -3 times 2 -7. So mu becomes what? Negative cancel out from both sides. And I get it this one. So 0.3 into 7 divided by 3. And I get 0.7 friction, coefficient of friction. Because he was asking us find a coefficient of friction between along the horizontal ground track. So what is the plan? What I have done in the whole story. Problem was not this speed we have, we knew, but this speed was unknown. So first of all, with the using a law of conservation momentum, I found this initial speed. When I got initial speed, this initial speed, u I given as a this is becomes final speed just before hitting. I think clear idea. And then I using this data, I found acceleration, and net force equal to ma. All right. So then I got it. F is equal to mu r, and ultimately I got, because I have acceleration. I can't solve this question until unless I have an acceleration. And I believe the point is very clear, and question is completely over. This was a little bit hard idea, but I hope so. Your concept is very, very clear.